Okay, in order to compile the firmware, I like to use Visual Studio Code rather than the Arduino IDE. I find it much easier these days to use. So the first thing you do if you haven't got it is download Visual Studio Code. You can download it for Windows, for Linux, for Apple. So take your pick. I will actually show you in a different video using the new Raspberry Pi 400 as a development station for things like this, but for now we're just going to do it under Windows. So you download the appropriate version for your version of Windows. I'm using the 64-bit version, but you pull down the one that you need. Once you've done that, and I've already downloaded it and installed it, it's just the standard way Windows does everything, so it's pretty easy. Then just close this down a second. We'll load up, so Visual Studio Code loads up like that, so we just fire it up. So this is Visual Studio Code. Now I've already got the auto build Marlin installed, but I'm going to show you how to add the two add-ons. Pretend I don't have these in at the moment. So what you would do is on a brand new install, you would go into this icon, the little squares, and you would click on for extensions, and you would search for PlatformIO. If you just do platform, you'll find it. Currently, as of today, it's 2.2.1. So it's the PlatformIO IDE. You click that, install it. Mine's already installed. And once you've done that, the other one that I use that makes life very easy is the Marlin Auto Tune. So Auto Build Marlin. So you just type in the search, Auto Build Marlin, and you'll see it's at 2.1.31 currently. And just install that as well, and you'll end up with these two icons on the left hand side of the screen. So that's all you need to do for that. Now we want to open a project, so we'll click on the PlatformIO, click on open. This is just going to load up its default page. Marlin is, when you download it, has all of PlatformIO capabilities built into it as well. So for downloading Marlin, you can go to GitHub and you can download Marlin firmware. So you can either go to marlinfirmware.org and click on the download. You can choose to download either the latest release version, which is 2.0.7.2. You can download a zip, or you can download configurations, or you can download the nightly build with bug fixes, which is Marlin. It shows up as 2.0x, which is actually probably a 2.0.8-ish. version inside here. It's slightly ahead of the latest stable releases, so that's the one I was using before. Why don't we do a latest release right from the get-go? All right, so that's 2.0.7.2. So we're going to download that, and we're going to download the configurations. All the configurations for a lot of the popular 3D printers is already set up for you, so you can just download them. They used to be part of the main Marlin build, but now they've separated them. So you just click on download. Make sure you get the right one for the right version of Marlin. And we'll just select download the zip file. And that'll bring down the configurations for the releases. And if you look in the file that gets downloaded, let's just get that out of the way. You can see we've got Marlin 2.0x, configuration releases 2072. So we'll expand these out to a folder. What I'll do is I'll create a file on the C drive to put them in. I've already done that. So we've got Marlin. Here's all the downloads. I'd done them previously. And we will open up the configurations for release. So just right click and extract files here. So we'll just do that. So these are all the configuration files, and we'll bring out the non-bug fix one. We'll bring out the standard release. And we'll extract here. All right, so here's our two folders with the files that we want. Now, the first thing we have to do, if I look in here, you'll see it's got PlatformIO files, etc. And then inside Marlin, within the Marlin 2.0x, is the actual source code. There's two files here, which are configuration.h and configuration.adv.h. These are the two main configuration files for when you're tweaking Marlin to make it your own. These are set for defaults right now. What we want to do is have ones that are relevant to the Ender 3. Now you could pick Ender 5 or whatever the other printer you have. So go into configuration releases, and we'll go into config. And here's the two default ones, which are probably the same as what's in that other file. We want the examples, and you can see there's a lot of different manufacturers here. Okay, we want Creality, and we've got CR8s, CR10s, S4s, S5s, V2s, 10Ss, CR20s, Enders 2s, 3s, 4s, and 5s. So we want the Ender 3 because that's what I have, not a Pro 1.5. What I have is the Ender 3. So go in here. Now you've got a whole selection of different controllers. So I've upgraded to Creality's own board, which is a 427. But you could equally use a SKR Mini, Big Tree Tech, E3 Turbo, etc. That's not what I'm using though. I'm using the 4.2.7. So we've got 4 files here. So we've got configuration.h and advanced.h. These two have been tweaked to pull up the right pins files and various other things and the parameters for the Ender 3. The status screen just defines the main screen that you're looking at. So if you look at this, you can see the position of the nozzle and the icon for the nozzle, the bed, etc. You can actually adjust those slightly and put in the words Ender 3 if you want or not within status. We'll look at the file's contents in a moment within the PlatformIO. The boot screen is a custom logo that you can use that lets you, it shows the Ender 3 logo by default, but you can make your own. And I have one for the breadboard as well that I use occasionally on some printers. Okay, so we have the 4 configuration files here, bootscreen.h, status screen, configuration.h, and configuration advanced. We want all of those, so we'll just copy those and we will paste them into the Marlin folder. So we go into Marlin 20X, Marlin, and paste them in here. I've already just done that. I just forgot to switch my screen, so I'm doing it again. And overwrite, you'll normally just overwrite the 2 files because they're normally by default is not the boot screen or the status screen overrides. So that's in there. So now we can minimize that, go back to the Visual Studio Code with PlatformIO. If you haven't already done so, just click on the little alien face. It'll bring up this screen here. Click on Open, and then this will open up the PlatformIO IDE screen. Go into Open Project. Navigate to your folder. So in our case, C:\Marlin /Marlin 20X. And because it's got PlatformIO and everything else in here, that's that you know it's the right level. So click on Open. It'll take a second to open it. Okay, and here's all our file folder structure. So you may get some messages pop up from PlatformIO for drivers and various other things from time to time. If they're appropriate for what you're doing, then just install them, update them, whatever you need to do. Yeah, the internals of PlatformIO.ini is the normal, if you like, older way of configuring for multiple platforms within PlatformIO to compile Marlin firmware, and there's a lot of things in here. The top bit here defines where you're going to start off from. So your default environment is for an 80 mega 2560, which is what most of the older controller cards used. And then you've got a whole bunch of different includes, source file requirements, etc., in here. You can see this is quite a big file, and it has a huge amount of different environments for SAM chips, for ARM chips, for Atmel chips, etc. There's a huge amount, and it's a bit of an art to figure out which ones you want. There is now an easier way, which is using the auto build Marlin. Okay, and what it does, it actually looks at the configuration files that you're using for Marlin. So if we go into the Marlin folder, here's our configuration files. So before we go into the 2 main config ones, I'll just quickly show you the boot screen and the status screen. If I just load this up, this is basically a binary representation of the Ender logo and a couple of things saying the layout for the screen. All right, that's all that's in it, very, very little. There is an application out there that will let you take an image file and turn it into one of these code compatible files for Marlin to use. You can see on the right hand side here little version of the logo. You can see what it looks like. So that's what's in here. So this is the boot screen. So this will pop up very quickly as you power up the printer. And in the status screen, this one has a little logo that it's putting up, which is probably just says Ender 3. Can't quite see very well here. And defines the layout of where the hot end animation is, etc., etc. So you don't need to worry about those anyway for editing them. It's a little bit more of an advanced thing. So let's open up, get rid of that one. I'm going to open up the configuration and configuration advanced. So the first one you'd normally go into, now as I said, this is we've taken the sample, so this one's already been tweaked for the Ender 3. So the first thing that matters is the configuration H version. This is set to 2.0.0007. If you download and use the bug fix version, it'll be 2.0008 currently. And if you try to compile that one with this version of Marlin, it will fail and give you a warning that the versions don't match. So you need to fix that. Down here is the author name. So somebody called Dust had set up this one, and they've put it in as the Ender 3. This would show up in some of the info screens for the printer when you go into the menus. So there's a few defines for showing the boot screen, showing the custom boot screen, and the status screen. You can save memory by taking these out if you were in a situation where memory mattered, where you were limited. Serial port definitions, baud rates, and the first thing that you can tweak to have a little bit of fun with is this one here, custom machine name. So this currently says Ender 3 4.2.7, which is very informative and things like that, but a little boring. So I'm just going to change this to say Peter's Ender 3. Okay. Not one extruder. Verify that the filament diameter is set correctly. This 1.75 is typical these days. There's a whole bunch of different parameters. I'm not going to try and go through all of them. I just want to quickly touch on the ones that matter, because most of these are already set. Actually, some of the things that are up here that do matter, but they are already set for you, are the motherboard, which is in my case the Creality V427. Depending on what motherboard you're using, that would be different. And as I said, the easiest way to start is to grab the example files and go from there. You may need to tweak it beyond that, but that's where you would start from. So we're going to go down here. A lot of these things we don't have. We don't have any tool heads. We don't have any mixing extruders. So we've got the temperature sensors that are available. There's a whole list of them. Typically we're using a type 1, which is a little thermistor. And for the bed, it's also a thermistor. Heater minimum temperature. This is when you start setting the on the console on the screen. When you are in here and you want to set the temperatures using the little dial and things, you can tweak that for the minimum that it'll let you set. And then you've got also, where's my mouse gone? You've got the maximum for each of the things that you can set here. So that's normally set to 275. If you're not using an all metal hot end, I wouldn't increase this. This will limit how far up you can drive the temperature to. When I put in an all metal hot end in my Ender 3, I will up this to about 300 degrees, maybe a little bit more. PID tuning settings. So if you find that defined PID temp is commented out and you want PID tuning, you need to enable it. This is already enabled by default. That just means that PID tuning is there. It doesn't mean that, the use of PID is there. It doesn't mean that it's necessarily giving you the menu to tune it. That would be down here where you've got, so this is the enabling PID, and then down here you've got the edit menu, which means it will show up in these screens. And you've got the auto tune menu, which also would show up in the LCD screen for you. So that you don't have to just use the terminal. You can do it straight from the printer without a computer or anything attached. So now here is where we have to change the values. These are the default ones. Let me just bring this up, shrink it down a bit. So you can see here the values that are there by default is 21. We've got 17. I is 1.54. We've got 0.93. And D is 76, and we have 82. So the easiest way is they give you the format right here. We just copy that from what the tuning gave us. We'll copy that, and I'll just put it right in here. Obviously get rid of the receive word and adjust the tabs to match what's already there. So now we've got the new ones, and we'll just comment out the old ones. I'll leave them there as the default ones. You can do a more elaborate programming, but it's not necessary. So now here's my new parameters that should match my system. If you want to have the heated bed use PID tuning, here's where you would enable it. A lot of other things are pretty much the same, the default parameters, etc. And you can, if you enable this, you will get a PID tune menu for the bed as well, which means then you could run an auto tune and tweak that too. The benefits is you'll get a smoother temperature for the bed over time rather than bang bang, which is what it uses by default. But not all controllers can handle that, and also not all the MOSFETs can handle it. If you've got a good MOSFET that doesn't get too hot, then you'll be able to handle this. It switches a lot more frequently, a lot faster. So the MOSFET potentially could get a lot hotter. So just be aware, you got to check, make sure your system can handle this before you enable it. Okay. Preventing cold extrusions. This protects your head and gearing in the extruder, so it won't let you move the extruder stepper motor unless your nozzle temperature is over 170 degrees. You can tweak this if you want to different values. I will occasionally set it to 15 degrees or something if I'm doing some testing where I don't have the nozzle attached and I want to, say, calibrate the distance that the filament moves to match what I'm asking it to move. Because when you set the steps per millimeter for the filament, it's not what comes out of the nozzle that you're setting, it's what's going into the nozzle that you're setting. So you could change this to do that. I think there's a way of overriding it as well in G-code. I can't remember off the top of my head. Prevent lengthy extrudes. This is to do with when your G-code is running, and it'll prevent the G-code from asking for more than 200 millimeters of extrusion length to be done in one go. So 200 is usually more than enough, but it could be limiting if you had an auto load extruder or something, and maybe it's quite a big bed and 200 millimeters is just not enough. But usually you don't have to worry about this. These are important things here. You've got thermal protections, configuration parameters. So protecting the protecting the hot ends, protecting the bed, and if you had a chamber as well. What it does is it enables algorithms that look for thermal runaways or underheating and things that would stop your printing from happening, and stop fires. So if if your thermistor came out of your hot end, and so your computer decided to, or your printer decided to then just start piling the heat into the heater on the hot end, it would just go up to 300, 400 degrees and more, potentially set fire to things and melt things. What this does is allows the printer to monitor the temperature, and if it's piling heat in and it doesn't see changes in temperature for a certain amount of time that matches what it expects to see, it will kill the printer from doing any more work and shut down as much power as it's able to. Okay, machine type, Core XY, etc. We've just got a standard Cartesian printer. We don't have to change or enable anything here. For my Tronxy X5S, I would enable Core XY. Homing, pull-ups, these are all set for us. We don't need to change them by default. All right, this is an important one here. We're down in the selecting the stepper drivers now. Now, even though we've got the 2225s, they're exactly the same from a physical perspective as the TMC 2208s. All the commands are the same. They're running in standalone mode on the particular board that I have anyway. So I would just leave this as 2208 standalone. That will drive the 2225s exactly the same way. If I had a different board, say one of the Big Tree Techs or something like that, or different drivers in, then I would pick the driver that was appropriate for the drivers that I have. These are the correct ones for mine, so I'm just leaving them alone. I won't be enabling anything like the BL Touch right now and things like that. So I'm going to leave everything else as it's set because it's already set to use the right board with the right pins, etc., etc. And we don't have any extra stuff to add to this at the moment. There's a few other parameters here which we'll use when time comes to add the BL Touch and things like that. Pretty sure there's nothing else we need to worry about. So, okay, configuration advanced is again somewhere where you may want to tweak things, a bit more of an advanced area. You shouldn't normally have to play with configuration advanced.h. When you get into BL Touch, there may be some things in here, and we'll look at that when the time comes. But for now, that's the only thing that we're going to look at. How do you compile this the easy way? Well, because this file, configuration.h, contains the board name, the machine name, and everything else you need, which will include the processor type, etc., that's on this board. It's all in here. It actually doesn't need to use the default PlatformIO.ini file to do it. If you go to the, once you've tweaked things and saved them, let's just save this. We did a little change here. There is one thing I do want to change. Sorry, it was a bit further down. That is, I like to, and you can do this yourself as well, if you want to. I don't use ABS very much at all. And there's a menu in here. Here we go. Preheat constants. There's two menus you get, which is got for PLA and ABS by default. I always run my PLA at 210, so I'm going to change this preheat to 210. You can actually change it in the menu system as well. And I run my bed about 60 degrees. So you can change the values. My preheat fan speed, I'll just set that to 128 as well, half speed. And for ABS, I'm going to you can actually change the name of the menu too. So I'm going to put in here PETG. I think it'll take 4 letters. And the preheat temperature is 240, but the bed temperature doesn't have to be that hot. And we can bring that down to, say, 50. I'll have them both. We'll change that back to 40. Okay, so we've tweaked those, and we'll leave we'll set the preheat fan at 128, so half speed. I've changed the menu a little bit there, and we'll see that when I compile and put it in. So we'll save that, and now we're ready to go to here. So if you click on the Auto Build Marlin, all right, it brings up some different menu items up the top here. If you click on the hammer, it will go into the compile mode. It'll automatically detect some of the menu configuration items out of configuration.h. So it's picked up the configured by dust ender 3. Actually, when this is done, I'm going to change that because we're tweaking this, and I'll show you what it does. It's picked up the correct firmware value, 2.0.7.2. It knows it's using a Corality v4.2.7 board. It knows it's using an STM32F1 processor. So it effectively will put together a temporary PlatformIO.ini for the compiler to use. You can see here it's actually downloading packages as well that aren't in by default from Visual Studio Code or PlatformIO. So it'll pull them down as it needs them automatically from GitHub or wherever it's configured to pull them from. Once it's done this once, the subsequent compilations are not going to be anywhere near as long. So let's just let this do its thing. As you can see, it's pulling in quite a few different things. But the nice thing is you're not playing around with complex configuration files. You can just focus on exactly what your printer needs within the configuration.h, and this Auto Build Marlin will do all the work for you. Ooh, you got a failure. Sometimes the first time you run a compile, you may get a failure, but I found that sometimes if I just simply rerun it again, it will work. So let's just try that. We just click here and build it again. I think it's because it's pulling down all these libraries and various other things. You can see this time it's not pulling down any files because it's got them all downloaded. There may have been some cross dependencies on some of the files that were compiled earlier as it was downloading, which may have been why it failed the very first time. And this is a pretty new well, I've never compiled this stuff before, as you can see, because it's pulling down all those files. This is not the fastest of computers. If you've got an i7 fairly modern, it should compile much quicker than this. This is using an older i5 right now. That was just a warning, not an error. And this time it's worked. So as you can see, the first time round it may not work. Second time round seems to have done everything correctly. Now before I show you where the bin file is, I want to just change one thing here. I'm going to go right back up to the top because I'm tweaking this config file. I'm effectively now the new author. So we'll come down here and we'll change this to say the breadboard, and I'll file save, and everything's saved. So now we go back to the, whoops, didn't want to do that, back to the hammer, and it should pick up there. So you can see the configured by, now it says the breadboard ender 3 instead of dust ender 3. So you can tweak that. If you start messing around with your own config files, you can put your own info in. Nothing wrong with that. This is certainly much more informative as well. You can see it tells you the date when it was built. Under machine name, it's that. It also tells you it's a Cartesian machine rather than a Core XY. It tells you the default parameters for the printer. So it's a 235 by 235 by 250 millimeters, X, Y, and Z, with one heated bed, single extruder, etc., etc. And it tells us the full processor name here, STM32F103RE. Now, I had some people in previous video saying that I should have gone with a Big Tree Tech one as well instead of this one. It's a little bit cheaper, and it may be. Depending on which one you get, it may be a little bit cheaper and things. But I wanted to use the Creality one through and through, just to show you, because it's the firmware is provided directly from Creality, albeit it doesn't always necessarily work out the way you want it to, as we found out. But it is fully supported by Creality for a Creality printer. As soon as you start deviating from that, you're really on your own, except for community forums and things. I do have two other printers that I have actually put Big Tree Tech boards in, and they are very capable. But right now I wanted to show one using the official Creality's own upgrade board. Anyway, we're done. Now, once it's done compiling, you get a little folder symbol here. If you click on it, it's going to take you right to the correct folder for where the bin file is, and we see it here. The format of this bin file, I've seen a few videos on YouTube that says, oh, it has to be exactly this, don't tweak the name or anything else. It actually isn't that important, the name. It needs to end in .bin, but it could just be firmware.bin. It could have all this in, and if I go to the, let me just copy this actually, because we're going to need this one. Copy that. If I go to where I put my firmware that I've done before, you see these bin files, I'll zoom it in a bit. These are ones that have come down. They start with ender 3. The file formats for the names are all different. The only thing that's in common is they end in .bin. And I found that the date doesn't have to be newer than the one that's currently installed. It uses the, I believe, the modified by, sorry, I think it uses the create date, not the modified date. Anyway, whatever it uses, I've put in older files and it's reverted back to that, so 2.06. If I put in a later one of these 2021s, it'll go in, and then if I wanted to go back, which is what I did for this video, I put in 2.0, sorry, I put in V006, which goes right back to October 2020. And then I went back to some 2021 ones, which is the one that's currently in there now. So let me just put the bin file in here just so I have a copy of it. So this we'll just change the name to say ender 3 Peter firmware. So it's my firmware. All right. Now let's get the SD card. Got to grab that out of the printer. So we'll copy that on the SD card. We'll boot it in. You can see right now it says Ender 3 up there. Settings are stored. If I turn the printer off and back on again very quickly, you can see this is the bug fix version. And you can see at the bottom here it says that little bit of text that says Ender 3 427 ready. If we look in, where is it? Octoprint, we see there is a, let's go connect first. Connection, connect. We will get a little bit of an info warning that it actually knows that we're actually running a development build. This is because we've got the bug fix version in there. So it may be a little less stable. So if you want to have just absolute proven, more stable code, don't use the bug fix versions. And you'll see this will disappear when we do the upgrade. So I'm going to plug this into the computer and copy the bin file onto my SD card. Let's just get rid of both these files. As we know, that's what we've got to do. And delete. And we'll put in the new firmware, which we just created. So you can see, oh, actually, just to prove the point about the names, let's delete that. Let's grab the one from here that I just named Peter's firmware. So it's a completely different file name format. Copy that. And we'll throw it on the SD card. Okay, so it's certainly longer than 8.3 file naming convention, and it's certainly got a modified file name. Let's just pull that. We'll go stick it in the printer. Let's bring up the printer's screen here. So I'm going to put it in the printer and then cycle the power. As soon as we see the Ender 3 logo, we'll know it's done programming. No, reflashing, however you want to call that. Here we go, booting up. Yep. Okay, so we've got the EEPROM version error, which of course, you know, we put in different firmware. We put in release firmware now instead of other ones. So we do want to reset the firmware, EEPROM. So we'll just do that now. And we're back up. Settings are stored. So everything pretty much looks the same, but the settings stored has overwritten the menu that I'd normally have there. One sec. So you can see on the subsequent reboot, it's pretty quick. And now you can see at the bottom there, it actually says Peter's Ender 3 is ready. So you've got a little bit of custom text there. So I'm just going to show you the menu printer info screen as well to show you that the other information is shown up. So there you can see it says Peter's Ender 3 is 2.072 instead of 2.0x debug build. And so it's picked up all of our parameters. We know it's got the newest firmware. We know the file name didn't make any difference. What is key is to have the .bin and to have it SD card formatted FAT32. I found that it's very difficult to format anything over about 8 gig with Windows to FAT32, so it's easy just to stick with an 8 gig, or anything way smaller will also do, because the file size is pretty small. I think these files are only they're under 200K, so around 200K. So anything SD card wise of a few megabytes and up to about 8 gig will do perfectly fine for programming. We should, oh yeah, so now if we go back to the screen and we'll bring up Octoprint again and we'll connect. You shouldn't get any errors this time showing up, no info screens up here or anything like that, because now we're running fully fledged software. Like it's release software. Oh, and you can see we can stop that from happening. Got the firmware Marlin 207, source, blah, blah, blah. Marlin protocol version, machine type, Peter's Ender 3, extruder 1, etc., etc. So if we do an M503 and scroll down, we'll see there is our new PID settings that we put in. Go back to our notepad. All right, 17.51. 0.93 and 82.48, exactly what we set in the firmware. Perfect. So that's that done now. Let's just try and see if or how well the temperature will work, and see if it get there and how well the PID tunings work. So we'll go in here and we'll set the temperature to 210. Oh, we want to set the fan going first, so we'll set the fan on. Oh, I want it at M106 space S128. So we'll set the fan at 50%, and we'll set this to 210, go. So you can see the little red lines dropped up here. See how well it catches up to the set point temperature, and see how much wobbling it does cycling at when it gets to temperature. So while we're letting that happen, I think that's pretty much everything for this video. I wanted to show you how to do a little bit of custom, or compile your own custom version of Marlin. For, in this case, it was an Ender 3. For any other printer, the process would be pretty much exactly the same. I have gone into complex or complete detail of the config files in earlier versions of Marlin. I think now that we're fully running on 2.0x, I think I may go into a complete configuration of one. Once I put in the all-metal hot end from E3D, I will need to change some of the parameters anyway, so I'll include a comprehensive run through what you need to change for the printer. I also do have another printer which is almost the same as the Ender 3, except it's got direct extruder rather than a Bowden tube, and I'll be changing that to use a Big Tree Tech controller, and we'll look at setting up that printer to fully configure the configuration.h file for the bed, the height, the XY parameters, the stepper drivers, etc., etc. Because I'll probably configure that one to be sensorless homing and things, so you wouldn't have micro switches or inductive sensors or anything on the end stops. You would just use the stepper drivers to actually do that. All right, so how far did that overshoot? It doesn't look like it did overshoot at all. It came back down. It's currently sitting at about 207. I asked for 210. Let's just run that for a few more another minute or two, just to have a closer look. You can actually see on a regular basis the temperature readings being output if I just unsuppress them. All right, so here's where we set the temperature. So you can see it started heating up, gets to about temperature here, goes over, only went up to 211 from I asked for 210, it went only to 211. It dropped back down to about 202, 203, and settled right in. So if we look at the temperature cycling, you can see that that's a much nicer profile than the previous one. So anyway, that's how to upgrade your Ender 3 with a custom firmware. Set your own friendly name for the printer and things like that. It should apply for an Ender 5. All the config files are here. The ones that I've done myself that I've tweaked, I will get around to putting them onto my GitHub page so that you could just download them if you wanted to. But as I say, most common printers defaults for a lot of different boards are here, and if you want the latest of these, you just got to go to GitHub, Marlin firmware. You can download the main Marlin, and then you've got the marlinfirmware.org rather than GitHub. You can download them here, all pre-ready to go. You just have to compile it. Pick your right config file, then compile it, and that's all you've really got to do. As you've seen, if you want to start using Octoprint and programs like that, and you want to get rid of all the warnings and errors that it's telling you, then you need to go and do your own until Creality gets their act together and gets the later versions. I mean, they are using Marlin 2.01, but we are up to 2.072 now, so a little bit later. Octoprint, pretty easy to use. You can see, look at that. That's really nice. That's it. So I think that's all. I'm starting to repeat things, so I'm gonna call it quits here, and I'll see you in the next video. If you like this one, give it a thumbs up. If you don't, well, don't. It's up to you. And we'll see you again soon. Bye.